Feeding the Future: How China's Smart Pet Feeders Redefine Care. Introduction. Welcome to today's episode. It dives into an area of technology that's both adorable and deeply sophisticated: the design of intelligent pet feeding systems.
智能宠物喂食系统
We'll review a fascinating 2025 research paper from Sanya University by
负三例
which presents a microcontroller-based smart pet feeder capable of timed, measured, and remotely controlled feeding through a mobile app. This study reveals how China's Internet of Things
物联网
and embedded system innovation are quietly reshaping the bond between humans and animals. Background: why smart feeding? In modern urban China, more than 70 million households now have pets. The researchers note that feeding alone consumes significant time and attention. Long work hours mean many owners struggle with irregular feeding or overfeeding. The authors call this the urban solitude of pets.
宠物的城市孤独
This emotional framing is powerful. Behind every smart feeder lies a deeper wish to care, even from afar. Irregular timing,
喂食不规律
imprecise portions,
食量控制不精准
lack of remote oversight.
远程监控缺失
Enter the STM32F103C8T6 microcontroller, the brain of the system, capable of real-time control, low power consumption, and multiple sensor integrations. Insert diagram 1. System overview. Perception decision execution loop. System design and function. The feeder's architecture follows the perception decision execution model.
感知决策执行
Perception layer.
感知层
Weight sensor HX711 tracks food storage and dispense portions. Infrared sensor TCRT5000 detects when the pet approaches. System design and function. The feeder's architecture follows the perception decision execution model.
感知决策执行
Perception layer.
感知层
Weight sensor HX711 tracks food storage and dispense portions. Infrared sensor TCRT5000 detects when the pet approaches. Temperature and humidity sensors monitor storage conditions. Decision layer.
决策层
The STM32 microcontroller processes sensor data, applies control algorithms, and coordinates tasks via a real-time operating system. FreeRTOS. Execution layer.
执行层
Servo motor, SG90, dispenses food precisely. OLED screen and buzzer provide feedback and alerts. Bluetooth module, JDY32, links to the smartphone app. Algorithm highlight, APID.
比例积分微分
Algorithm adjusts the motor's duty cycle to keep the weight error under plus or minus 2 grams. Impressive for low-cost hardware. Insert diagram 2. PID feedback control loop. Smart app and user experience. The software side uses App Inventor, a drag-and-drop visual environment. Through the app, owners can set feeding times, adjust food quantities, and monitor data in real time. When the pet nears the feeder, the OLED display shows pet in, yes, and the app echoes that information instantly via Bluetooth. If food runs low, both the screen and the app issue a warning.
警告信息
This bidirectional communication between owner and machine, mediated by sensors, turns technology into an empathetic bridge. One could even see it as the embodiment of human-machine interaction.
人机交互
Insert Figure 3. App Interface Flowchart. Testing and Performance. During laboratories testing, the researchers simulated feeding sessions using a 70-gram wafer, mass of an average handful of dry kibble. When the preset quantity was reached, the server automatically stopped, maintaining a deviation of less than 3%. The Bluetooth indicator changed from flashing to steady when the app connected. Visual feedback confirming synchronization. The team tested 4 core modules. OLED display real-time data output stable, clear readout. Servo motor timed food delivery precise, repeatable. Senior sensor pet presence detection reliable trigger. Through these modules, the feeder achieved precise feeding,
精准投喂
remaining food monitoring,
余粮监测
and remote control.
远程控制
Insert Figure 4. Physical device photograph. Innovation and future directions. Despite success, the authors identify several next-generation goals. 1. Cost optimization. from 150 yen to under 100 yen using local chips like GD32. 2. AI enhancement, integrating
图像识别，
image recognition via ESP32 cam to analyze pet eating behavior. 3. Sustainability, adopting solar charging
太阳能供电，
for cordless operation. These improvements could make smart pet feeders more autonomous, personalized, and eco-friendly, aligning with China's broader smart home
智慧家居，
or revolution. Conclusion and reflection. This project demonstrates how embedded systems, sensors, and mobile interfaces converge to transform everyday care. At its heart, the feeder represents not only technical control but also the emotional extension of companionship through technology.
情感延伸，
Reflection questions for listeners. 1. Could algorithmic caregiving deepen or dilute emotional bonds? 2. How do we balance autonomy and affection in AI-mediated relationships? 3. What ethical standards should govern data collected from pets and owners alike? Artificial intelligence and robotics research.
人工智能与机器人研究，2025-14-5-1087至1098。
Published online September 2025. Intelligent Pet Feeding System.
智能宠物喂食系统，
Smart, automated pet feeder. Internet of Things.
物联网，
Interconnected smart devices. Human-machine interaction.
人机交互，
Communication between humans and machines. HSTM32 microcontroller STM32.
单片机，
Core processor controlling system. Servo motor.
舵机，
Motor that precisely controls angle position. Infrared sensor.
红外传感器，
Detects pet presence. Weight sensor.
称重传感器，
Measures food quantity. Real-time clock.
实时时钟模块，
Keeps accurate timing. Bluetooth communication.
蓝牙通信，
Wireless data link. Remote control.
远程控制，
Operate system from afar. Data fusion.
数据融合，
Integrating multiple sensor inputs. Image recognition.
图像识别，
Visual analysis by AI. Solar power.
太阳能供电，
Energy source from sunlight. Emotional extension.
情感延伸，
Emotional link via technology. Stay connected.